First, a very warm welcome and good morning to all of you. I don't know whether I'm in the right forum or not. We are going to talk physics. How many of you still can recollect, okay, escape velocity, yeah? Just a recent past, there has been a little bit overdose of rocketry. Right? There are a few movies and there's a whole bunch of conversations going around on that, and that inspired me to pick the topic, escape velocity. Just to orient everybody before we get into what's in the content. Primarily, the gravitational force, the atmospheric pressure, and if you really want to get out of this and then fly into the planets and all those good stuff, you need something as a velocity, as the power to break this barrier, right? So that's and the rocket that people built is very, very powerful, right? But unless until it breaks away with this escape velocity, it will not do or not give you what it was designed for. The exact simile or a parallel to AI, right? Now, a whole bunch of people here, data scientists, data engineers, ML engineers, so I don't have to really deep dive into what does AI means. So, I'm assuming all that. But in AI, what happens is you need a lot of data. It is very data hungry. You have got a lot of powerful algorithms, and we continue to make progress on that. And over the last 4 or 5 years, or going a little bit further, the hyperscalers and many, many more platforms has come out which has even become more powerful, right? And that's what the AI Flywheel is. Now, we have powerful platforms, powerful algorithms, lot of data now becoming available. This flywheel is supposed to deliver what it is designed for. But there are problems, right? There are challenges in that and why it is not delivering. And in my hypothesis, my understanding of the concepts and talking to many clients and practitioners like all of you, it needs that escape velocity, right? So this is where rocketry, escape velocity, AI flywheel, and we are in a search of escape velocity so that it will do the momentum why it is designed for. There are 2 pictures here. One is the AI-driven growth and more opportunities and risks. And in the previous session, there was a question around the rightful usage of data or more usage of data and availability of data, but there is risk along with that. Of course, this data going into models and then delivering the AI solutions that we are all coding for, imagining for, and then life is going to become great and good. It needs observability and governance, right? Without that, things will be out of control. And infrastructure and operations to quickly provision, quickly manage, quickly monitor, and stay on course. And that kind of flywheel generates more customers, more data, more users, more use cases, right? And hence, it is a vicious circle. Now, if I go to the task level of the view, what you just said, AI-driven growth, that is good, fantastic. But at the task level, it is a lot of data. And this chart shows, right, a disproportionate amount of time being spent on data. Data collection, data wrangling, quality of data, organizing data, cataloging that data, and cleaning data, merging, matching. The world is full of data operations. Yeah. Probably compared to the data aspects, you look at the algorithmic interventions. You look at how do I model it, how do I deploy it. Those are tiny amount in the percentage of time spent, right? So this is actually a conundrum, that at one end we are saying that we have got fantastic algorithms, powerful platforms, we can just get away with all this mess and then keep doing use cases, solve very, very interesting, exciting problem statements. But at the other end, we are still pulled back by the mess with the data and the aspects and the time we spend on just to manage that data. So the challenges, apologies if you can't read at the back, but there are monitors out there, you can read it. Just for that, I have kind of bold, the few things that I wanted to talk about. Now, as the data volume grows, and we are just talking about the structured data, right? Labeled data as well. We have not yet figured out how to deal with unlabeled data, right? Then there is a whole world of unstructured data. Yeah, we have not even gone there in the full extent. So as the data volume grows, the size of the feature space, meaning all these features we engineer to feed into the algorithms, that also grows, right? And now imagine there are groups and groups of data scientists and data engineers and ML engineers spread out in the large enterprises and solving problems by department, by specific use cases. They're reinventing this wheel every time. So the reusability becomes the other question, right? Even though I have got all these powerful things at my disposal. That also takes it into what people are developing, and it is getting into the production to deliver the results. How do I interpret that? What is the auditing mechanism around it? There is no way I can find out who has done what, right? And of course, there is a feature hell. Feature hell is all about consistency. The way I wake up that day, and I'm a really, really fantastic unicorn data scientist, right? I know this shit more better than anybody else, yeah? And I will code it, I will define it, I will design it the way I think is the best way to do it, yeah? The other guy doesn't feel like that. They will figure out their different things, and then the other guy like that, yeah? So that becomes a feature hell. So there is no consistency on how you define what you do. And finally, the life cycle, right? Once it goes into production and then somebody else comes in, and nowadays, take it please with a spirit of joke, nowadays finding and maintaining and retaining data scientists is a big, big, big problem. All of you agree? Yeah? And people leave. You don't know what they have done. The next guy comes in, and then, of course, you paid 200% salary jump to get that guy. The guy comes in, and the first day looks at it, oh, this is all crap. Doesn't make sense to me. I will figure out my own packages from the back pocket and my own IDE to develop, my own notebooks, cheat sheets. It's a crazy world, yeah? They will create something. 2 months from now, this guy goes, hey, somebody else is giving me 300% jump. I'm gone, boss. Thank you. Now, that life cycle managing of it is becoming extremely, extremely challenging. And this is a real problem today, right? It's good for us and the data scientists, yeah? But hey. So the needs, right? Just to highlight and summarize on the needs, yeah? There is access-related patterns, okay? And what does this mean is the feature information from which sources you used, what kind of a feature definitions you prepared, how you are going to really materialize that, how much of that will be showing up in a real low latency online store versus what is going to be in a batch because it is not needed that way. This kind of a lineage and end-to-end information today, I bet, right? You walk into any data science, the most matured practice, you will never find this thing. Because either it is locked in the laptops, right? Or somebody else is really tightly governing it, so hence it is like, best kept secret, nobody will know, or it is locked down here. So first is this access to feature information. Yeah? The second is the serving aspects of it. The second is the serving aspects to it, meaning once you have got understanding about these particular features that people have painstakingly created and tested, trained, right? There's a lot of thought process has gone into it. The second becomes, okay, how it is served, which application is consuming it, when they are consuming it, right? Why they are consuming it, and what frequency they are doing it. So there is a lot of about availability in production with a high throughput and low latency. Those kind of things that needs to come in, which is on the serving side of it, right? Today, if you really look at, and I think the previous two sessions were also highlighting the same point, here is a problem statement. Data scientists, data engineers, ML engineers, designers, everybody start working on it. Take it to the pilot, and then after that, you leave it for the production guys to take it and do whatever they want to do. There's a big gap because what you have developed is not production ready, right? It is not deployment ready. And to bridge that kind of a gap, we need to find the serving patterns well defined around it so that the next group, when starts looking to solve similar kind of problem, they will not reinvent the wheel. Right? There is a baseline from where they can start. Then comes the integrity, which is today, when you look at the data and the models that you have prepared, there is a difference between the behavior, the performance, and all of that at the test and train level versus getting into the production and running it in a production level. The world is not monitoring, measuring all those aspects in the same plane. So what you have developed and ran as a pilot or even pre-UAT, right? And suddenly it gets into production, the next day morning you start getting alerts and emails, hey, I don't think this is giving the right performance, yeah? So what you guys have done is probably a lot more crap and nobody understands this, right? How many of people here from the IT support, IT engineering background, production, right? Some of you. The world, when we started in this IT journey, was always about deterministic applications, right? Which is the business applications that we developed and put it in production to solve business problems. It is deterministic because it has got 10 screens, 20 inputs to be given, there is some workflow built into that, and it will deliver what exactly it is designed for, right? So the IT support engineers, right, those are the guys, I really have empathy for them. They have got a run book, and they look at, oh, this job didn't run, that's why this screen didn't show this value. I'm raising a ticket, and then it goes back, somebody looks into it and fixes it. AI applications are not deterministic. That's a huge, huge and fundamental difference. AI applications are probabilistic by nature. It will recommend something based on what data it has gone through. Right? Now, in a probabilistic application scenario, there is no way to go back and look that here is the run book and go through this and see exactly this is what is going to happen because your recommendations are driven by probabilistic natures. And this is where the IT engineering team, the support team scratches their head, oh shit, I don't have a probabilistic run book, right? So this is where the performance, the statistics and measures during train versus what it is doing in production, there is a huge gap, and these need to come together, right? Then comes the convenience, which is primarily about, this algorithms, these notebooks, and then all this good stuff and complex math, crazy stuff that you guys are doing as data scientists. I'd have no clue about those because the output of it is not explainable. Right? It's very cryptic in nature, and it shows me some graphs and this RUC curves and AUC things and that, which you understand, nobody else understands that. Yeah? So how do you make it the algorithm itself as an API? So it abstracts the complexity, it gives me exactly what I'm looking for, and I'm happy with that. Right? This is where the convenience part comes in. Today, when we design and build AI applications, we don't even think about it, right? And maybe tomorrow there's a trend going to catch up, which is AI as an API, yeah? So if you hear that trend, please give credit to me. But that is where we are going to make it more convenient, more abstracted, more easier to interpret and understand and use. And finally, of course, autopilot, because we humans are lazy anyway. We don't want to do the same thing again and again, so we need an autopilot mechanism to every single thing, right? Now, if I zoom back into, we heard the challenges, right? We talked about it. We understand the needs to break away from these constraints all around to get the true potential of AI, right? Or get the AI flywheel in motion. So what exactly does that look like, right? So feature store, and that's in my view, that's the escape velocity. That's the equation that we need to match it into our AI flywheel. And this particular diagram, if it is visible to the end, you will find a bunch of things coming together, right? So there is one part of it which is registering and connecting to the data sources that you use to model, right, to prepare your features and engineer those features. It goes through, and it starts registering those in a centralized store, right? We call it centralized feature store, where you will find the repeatability, reusability, the definitions, the documentations around it, and if there is an API is going to be built, that is also registered over there. Then there is a facility to link it to an online feature store for really, really low latency, right? And there is an offline store where there are batch processing happening, and you really don't need those features to be available just like that, right? And of course, there is a monitoring, which is what it did during training versus what it is doing in production right now. Hence, you have got a traceability, a comparison, and so that when there is a problem situation arising, you can always go back and start looking into it, not to call the data scientist who had developed this probably 6 months back, and that guy is having fun doing something else, right? And this is a big problem today. And of course, the feature governance and all. This particular paradigm shift in terms of, how do I make it reusable, interpretable, convenient, integrated as well into my various notebooks that I'm bringing in or various platforms I'm working on, is actually going to give you that kind of a escape velocity for the flywheel that we were talking about earlier. Now, interestingly, you can ask me the question that, look, the AI is all about experimentations, right? And hence we should have the flexibility to experiment as many times as we want, to bring in as many different kind of tools fit for purpose as we want, and we should have that capability of a platform and processes and governance to run it as many times and when and where, right? Because solving a probabilistic problem is never a linear path. There are multiple paths, multiple directions people will go, multiple models they will compare and check, and finally they will choose something, right? And what you have chosen today, when you run it with the newer data in production for 3 months, you will realize, oh, this is not working. Now let me go back and pull out the other models that I had experimented with, and maybe those will work, right? Or I'll throw it away, and then I'll start experimenting from a different angle. Multiple experiments all the time, this kind of a thing needs to be also brought into the overall methodology that people adopt. So perhaps the data science methodology or the process and the tasks and all those things need to be relooked at with a feature store which is integrated end-to-end over there, right? And that's the escape velocity equation. So you can take pictures or look at it around. All we need here is decrease iteration time. I mean, we cannot say you cannot iterate more than twice, right? I mean, the first thing when there is a problem that we look at, we start putting boundaries around it. Oh, you can't do more than twice here. You cannot use this data here. You cannot look into these other packages which is not approved. like that, right? Just to make our life simpler, yeah? But that is not AI. That is not where you really get the power of AI because you are constraining all those things. And hence, we need this mechanism where you can do it as many times and it is all integrated into a feature store where decrease iteration time is the first criteria. Increased reliability is another criteria. Hey, what happened when I ran it 2 months back versus what I'm seeing now, right? And hence, can I backtrack? Do I have a lineage and traceability around it? And of course, let other people also look into the collaborative aspects and not reinvent the wheel all the time, right? That's the escape velocity equation, which if we apply to our AI flywheels, we will actually take it to Mars and then other planets and everywhere else, right? That's the similarity I wanted to address. For the architect mindset people here and the engineering mindset people here, this is just a simplistic way of how does this thing work, right? So if we go from left to right, you have got batch processing world, which is still, constitutes a large percentage of our use cases. And real time is probably a little less, but highly, popularized through the e-commerce and the smart apps and all those things that we carry around, which is more consumer-centric, right? And mission-critical use cases. But these are the two ways you bring in data. And from there, we start doing feature engineering, looking into those data. We spend, if you recall my earlier chat, we spend probably 80% of time just dealing with this data, features, engineering, quality, and all those aspects. So that is what comes in here. Of course, there needs a data ops kind of a, I would say, practices and implementations there. But this is where you pipeline, right? You build your automated pipelines over there. And then you point it to your offline data, which is more as a, how do I materialize this data and where does it go and store, right? With a complete lineage from source data all the way till the engineered features. For the ones which is low latency needed, you channel it through the feature engineering disciplines and put it on an online data store and Redis, et cetera, right? If you are wondering, these definitions are going into a feature registry, which is where the metadata information, frequencies, what kind of data sources it is referring to, what's the formula for that particular feature that I engineered, all of that is documented and stored in the registry with the links into when it can be materialized. Is it online or is it offshore? Yeah? And from there, your training data starts, your serving pattern starts, and finally, it kind of looks into the model, which is going into applications which are consuming it. So that at any given point in time, this feature store gives you the ability to iterate as many times as you want, and it reduces those iteration or experimentation timeline. It gives you this reliability because it is centrally stored now, and hence, when you come in, it is basically a version of truth for all your features that you have engineered. And it also gives you the collaboration aspects, which is diverse set of groups and people working on it. They can refer. They don't have to reinvent the wheel and use that. You can expose it as APIs into various consuming patterns, either your Jupyter notebooks or the fancied app that you have built, right? So this is that escape velocity, the real architecture that I've been talking about. Now, you can ask, give us a few examples, okay? Imagine now that you have built models, right, which has got different kinds of features, as you see here listed down. And this is for a retail business, if you may, where you're bringing in the internal customer data, the products data, the store data from where the people are buying, all of that kind of data. You have added more external data, which is what's the pricing happening at the competitors and footfalls and then whatnot, right? And you painstakingly engineered features around it. These features, you did it for a grocery store, okay? Now, there is another use case coming in from another business group which is saying, hey, I want to also find similar consumer-centric patterns, but my business is apparel. So the features that you had engineered earlier, right, which was very tuned and specific to grocery, and now you're looking at another set of features that you need to create, which will be for apparel. Apparel do not have expiry dates, right? Apparels are more about colors, right? The sizes and all, whereas grocery has got a very different set of characteristics that you need to model for, like that. Now, what people will do is when they get the second use case, they will throw away everything and then start looking at data, cranking it up, and more complexity thing. And the next day, there is a general merchandising kind of a use case comes in. Oh, shit. Let's all go back to the room, look at all possible data, start doing it again and again and again. Now, this is where the feature store comes in, right? The formula, yes, the data sets and the attributes may differ, but the core concept of that particular feature engineering is still with you in a feature store. And hence, you can restart and purpose those things and get into the training part of it, and don't spend 80% of time on just running around data. This is another example of the same things across omnichannel touchpoints and some of those aspects, examples I was talking about earlier. Good, I'm running probably short of time now, but quickly I will go, and this is the last slide. The question would be, okay, this is fantastic, right? This is kind of a little bit utopian world you're telling us. But for everything, if we start doing a feature store, then is that the right way to do it, right? And so whenever I look at a problem to solve, I first try to find out that who else has solved it fully or partially earlier. Is there a cheat sheet available? Everybody's familiar with the cheat sheets, right? Yeah? So here is a cheat sheet for you to navigate through and say when I should go for a feature store versus when I should not. Right? Because the problem needs to be solved in a very simple manner. Right? But we engineers always start doing over-engineering and make it more complex to arrive at the end result. So this is something as a takeaway gift for all of you that it's a very new concept. There are only 3 or 4 industry-leading products that are emerging, that are coming out. They're not even put to real production test yet. There is more going to happen as research and innovation in this area. So stay tuned. And this escape velocity for your AI flywheel, this is the real thing. And this is what we need to zoom into. Okay? Thank you for patiently listening to me.